This video is to give you some project board samples from high school projects that were done at research facilities. These particular project samples that I'm about to show you are actually projects that won Alameda County Science and Engineering Fair and advanced on to ISEF, which is the International Science and Engineering Fair. I want to stress that high school projects do not need to be done at research facilities. These are just samples of some of our best projects. Also, these boards were printed on screens, which is required for ISEF, but not for Alameda County. And so project boards that are those traditional boards from our original project board sample are the majority of high school and middle school projects, and they are allowed. So you do not need to print on screens the way these are. So the following projects are extremely complex and complicated. So I realize that you cannot read this project as I have the picture, but what I want you to take a look at is the format. There does tend to be a left to right progression, top to bottom. So while this is still a screen print, all in one, it is laid out as if there were 3 columns. And that's very similar to a traditional science fair board. And so this first left side reads top to bottom, and then you go to the middle and you read top to bottom, and then to the right and you read top to bottom in this last section. So as I bring and zoom in this project, you can now tell that it's actually an engineering project. And as you can see on this project, they did the same. They've addressed their problem, they have their central engineering goal, and they've started looking at existing potential solutions and design constraints. Project over here has that, and that's what this engineering kind of flow is looking at. If we zoom in, you can see what they were working to get as an end-all, be-all, end of their engineering design. And if we move this up, we can see that there was a whole lot that went into designing and engineering and computer programs that were needed, algorithms that were needed in order to get their final design. But they do have a component where they say, okay, this is where we ended up. This is our final design components and specifications and our system in general. So this project is definitely following the same method that what we're average to our high school project. You can look here, that they have a prototype testing section, and they've utilized different components to test, and they had a pilot study that they did, and they're explaining all of those various steps that they took to test their prototype as you go down through this flow chart. And they do have some data that shows what those tests came out. So this is much more complicated than just giving a survey and graphing what people think, but it does follow the same systems. So reminding you that engineering projects state a background and then name their engineering goal, and working down the paper, they will address design criteria and constraints and evaluate the existing products that already are available on the market. So that's this component here. And then as you look at this traditional board, you would take a look at your prototype, and you might have various stages that your prototype goes through as you're developing your project. So let's take a look and see if our is the flow of your project board when looking at an engineering. And so I want to remind you that even though you're doing an engineering project, you are going to have to, and your goal is to end up with this kind of prototype, something that you've actually built. Now, this might be a computer program, an app, a device. So you have some final product. And I want to remind you that you definitely must test it. So how you test it depends on what type of a product. So you might need to take it to people and ask them to answer survey questions about your product. You would then need human forms for allowing people to participate in your study. You need to collect some sort of data and then graph that data. And if you then go back to the drawing board and you do another phase, then you want to include that. It could have also been included up here, and then you retest again. So whatever your final stage is, you definitely want to get data and graph that results. So if we go back, so as I look at this next project, I'm looking to decide, is this an engineering project? Is this more of a traditional science fair project? And I see things like purpose and background. And then I look at a question and a hypothesis, methods, which would be similar to controls and variables. And then this data analysis section, it's very large. Discussion would be results and conclusions, what they'd like to do next, further research. This is their reference list. So this particular project is actually more of a traditional science fair where they came up with a question and they stated a hypothesis and they walked through the scientific method. Another project board. And we're going to zoom in. We can see it's just on a much more advanced level, but they have covered the same components that are required. This particular project was performed at a research institution, so the materials that they had access to and the style of testing that was done was going to be much different than what you can do at your kitchen table. So going back to what we look for as a traditional science fair project would be the scientific method, and we want to walk our project through these various steps. And so as we go back and we take a look at so again, I just want to reiterate that these lab-based projects do have a similar setup. They might look fancier, they might look a little more word heavy, but they do have the same components as we're expecting in our more traditional projects that you do in your garage or on your kitchen table at your classroom science lab. There are data and analysis to be performed. They recognize purpose and methodology and results for each component that they were testing. They draw conclusions and they look at future research. Now, this future research section is not one that we traditionally include on our projects, but it can be done. If you found an abnormality or you have a second round of testing that you would like to do and you didn't have time for, you may go ahead and add a future research component. I'd also encourage you, if you have time, go ahead and add this. You can do a second stage of testing for your particular project and make it that much stronger at our county fair. So if there's something further you'd like to do, instead of including it in this section like here, take it and go run with it and do another round of testing and get another set of data, results, and conclusions. And you've basically said, I've done 2 levels of this project, and you've taken it to a much higher place. I'm just going to show you these boards just to give you an idea of some of our other projects that have gone to ISEF and what these boards look like. Still has a problem, an objective, experimental procedures, controls, data and results, graphs, all the same components. And here's another one. Lots of pictures on this one to show the technology, to show the cells, what they were working with. But again, the same procedures for a scientific project are there. So I just want to end reminding you that the expectations for projects that come to Alameda County Science Fair are based on your traditional cardboard 3-part project board, whether you have an engineering project or a traditional science fair project, and that we are looking for it to follow the steps of the designed methods. And you can find the project proposal steps on the science fair website, alamedacounty.org or acsef.org, and that would give you the project proposal for your engineering project. You can also find the individual lab report, which follows the traditional science fair project display and creation setup. So look for those things and just use these as ways to strive to improve your board and what you are bringing to us at Alameda County Science and Engineering Fair.